Hello everyone, my name is Retrieval-Augmented. Thank you so much for the opportunity to giving me a task to create such an interesting project. So in this video, I will be showcasing you my project. It is based on RAG prototype on oncology research. So this AI powered assistant is designed to help researchers and students to get data, text generation quickly and efficiently and accuracy based on oncology related document and research paper. It uses advanced AI model and search vectors, search similarity search to enhance the accuracy of information that it retrieve. So it is built on three things like first of all I have for the front end and back end I have used uh, Next.js for the and for the retrieval, like for to implement RAG I have used Python as an also in backend. So and also my fine-tuned model is hosted on my AWS backend, like AWS VPS. So in Next.js, I have created an UI, a good looking UI that and also create an API that interact with our my Python backend that is mainly implemented on RAG, that retrieve the data and send it to the model. And in the model, when we are giving like a parameter like in JSON file, so the model will be our llama 3.3.2, and the message will be I have given the instruction with the context will be our RAG, that is get the information. It embed the data on, like I've also used for data storing of vector data such as an open source and lightweight Facebook AI similarity search fast, and also use fast API to integrate with it. So I've also used like to save the data. I've also used MongoDB to save the data, then retrieve it, and then my actual data like text files and research paper are saved on MongoDB. It retrieve the data and get embedding and information and add the context, like when the data are retrieved from my vector data, it add the context like message and context, gives send post to the our model, my fine-tuned model, and when I get the response it will show it on my UI project. So thank you so much. I will uh, showcase you my project. I'm excited to walk through you the Oncology Research Assistant project. This is RAG, Retrieval Augmented Generation model that leverages AI assistant to in oncology research by providing insightful responses based on structured and unstructured medical data. So let's dive to the system works. This is my architecture, as you can see, my whole architecture. uh, Before coding my project, I have created this architecture to understand how the data works flow. So let me tell you how I prepare my data for this assistant. So to ensure the high quality retrieval and generation, my data preparation process involved multiple stages of cleaning and pre-processing. First, I have collected oncology research paper in PDFs and document and other format. I am extract text using Python library. During extraction, I remove unnecessary formatting such as header, footer, and pages number to retain only meaningful content. Next, I have proceed text by tokenizing into a structured segment such as abstract, conclusion, and methodology. This is important for our good extracting data. So to standardize embedding, I remove stop word, normalized spaces, white spaces, and applied lowercase where necessary. The clean text I the clean text then converted into dense vector embedding using llama 3.2 embedding model. For the efficient retrieval, I stop I store the vector in a fast like FAISS index, fast index, mapping them into their corresponding directory in MongoDB. This step enable fast and accurate semantic search, ensure that oncology related queries return the most relevant research insightful. Regular update duplication are checked, performed to maintain the data integrity. So let's dive into our architecture. So the overall architecture, the oncology research assistant is designed to process user queries related oncology, retrieve relevant data from vector database to generate insightful responses using a fine-tuned model like such as llama 3.2 model. So this is my whole architecture. I have created mainly the front end and back end are developed on Next.js. So I have in this project I have two backend. First of all, I have backend in Node.js and then in Python. Why I've As you can see, I have separated like two backends in different languages, Node and Python, to uh, the libraries such as FASS, and to handle regression like RAG. It can be done best way possible in Python. So I have done Python and pipelining the data. Like I have created an API that pipeline data to our backend Node.js, so it communicate via my API. So let's go through our UI user interface. So the system start with a user interface where user input a query such as tell me about cancer. This query is sent to the backend via API request. My API would be dot dot slash API slash on Coregi chat. So this is my API that I have created. So this API can be sell or can be used by other project, can be integrated. So I have created such that we can use. So the backend is built using Nest.js and process this request by applying Retrieval-Augmented RAG. So in backend, when a user send a request, what happen in backend? The backend Node.js handle incoming requests and process the query. It retrieve relevant data by embedding documents such as PDF, text files using a vector database. For this, we use FAST, which help in generating high quality embedding for efficient search and retrieval. Once the relevant data are found, they are pipelined into our fine-tuned llama llama document. Whenever the query is revealed, the system search for the most relevant embedding, retrieve the related text and send it back to the backend for further processing. So I have used FAST for our vector database. Vector database is a high dimensional to this used for similarity search. It is created by Facebook and it is very user friendly to use. It is an open source, so we can use in however we like. So when going our model, I fine tune model. So I fine tune model using google colab google colab using unsloth. So the fine tune model are happen there and hosted in VPS like virtual uh, private server. I have done that, and then I have installed AWS. In AWS I have installed Ubuntu shell. Then I have uploaded my fine-tuned model on that. So the total interaction and data falling are going are happening throughout the our architecture. So first our UI send and request to our backend to handling like to handling requests. It sends pipeline data to Python. It get data and then it tells the llama to get the response, related response with context that we have get from our Python. Then it process and send back response to our UI that display our related information that we have that we have searched. So let me tell you about in detail our fine-tune model. For fine-tune process with Unsloth and Google Colab. For the further improve the model, we fine-tune it using Unsloth and Google Colab. This process enhances the model ability to generate precise and research back response. Unsloth allow us to fine-tune efficiently, optimizing performance while ensuring that our AI remains highly knowledgeable in oncology research. So next I will go through all the code how this works, and then I will show the implementation how this is working, and created a comprehensive documentation based on our oncology AI assistant. So uh, this gave you a brief introduction about the project and the installation part. If you want, you can try it yourself. It is very easy to use, like you can install. I have given the instruction how to clone the project, installing dependency both front end and back end, as well as our Python backend with FAISS API and Facebook API similarity search, and the given endpoint. You can test it out yourself and deploy it. So uh, let's get deeper into the project implementation part. So this AI powered AI assistant designed to assist researchers, student, as well as doctor in getting accurate research backed insights on oncology topics in real time. Cancer research is complex, and finding the right information quickly can be challenging. That's why this AI comes in, using a state of the art Retrieval-Augmented Generation. This AI assistant search vast database and provide well structured response based on a real research. So as you can see, the text that I have uh, built with, it is mainly built on Next.js. I have used TypeScript. As you can see in this, I have used TypeScript, JavaScript, Python, and CSS. Uh, it is mainly built on Next.js, and for front end and back end with our own API that I created for this project, and also another backend which is the RAG implementation or implement with Python. So if you wanted, you can try it yourself. I will show you the project how the code is implemented. So this is my repo. I have created two folder for this. This is my next project, and this is oncology vector backend. Like it contain the Python code, and this one contain our uh, TypeScript language project. It is a Next.js framework. So you can see I have in Next.js we get the we get Tailwind CSS as a default. So we go in app, and as you can see I have only added it is a simple UI, so I have only add in a page.tsx. So in this file, as you can see, I have write a lot of code. I will show you one by one how it is implemented, what I will doing, and what are the structure and how it is implemented. So first of all, you can see the type I have created for this project: chat completion response message. So this will determine the type of my message, the role, user, assistant, or system, and the content will be the content string will be our payload. The payload include model, role, and contact and content. Content is a message that include all our message instruction with context that in a payload that will be posted to our backend. So this is my main function on submit. When I will click I will show you on demonstration part. In demonstration part how this work. When we hit a button up, then this function fires up. This function on submit. So I have created my own API. Like, see this, I have created our own API. Let me show you soon. First of all, let go through the response. So I have not using Axios library for this, because uh, when we're fetching the model, I have seen I have get some problem while fetching using Axios. So I have used our Valena TypeScript fetch to get the content. In method I have used post to send a request. Our header will be content type application. We are sending a JSON file. So our what we are sending, the model what that we are llama 3.2, and the message, the role will be a user, and content, the prompt what the user are sending, and this will send to the our backend. So you can see my UI part. I have used Tailwind CSS. In demonstration part I will show you how this is work, like how our UI, and I have created very good UI with animation high level. I will show you. This will be the animation, a dot animation. It like just a typing animation, like you see in WhatsApp or iMessage. When someone is typing, it showing the typing message. So when the process are happening in background, this loading will show to the user. So see this, our form, our handle on submit handle, we are calling our function. So you get the idea how I am sending my data with this function on submit. This message sent to our API in root.ts. This is our main implementation. It sending request. You can see the Python server URL. So it sending for embed data, like when we are prompting some specific information about oncology research. So it will get, like, it send the request for a specific data, like to specific information to get the information. So as you can see, uh, the post requests are coming, are handled by this function, post function. I am getting my message and model. In previous, you can see I am sending my model and message in this. So the message and model are getting in this. Destructuring are happening using JSON. So we are destructuring the data, and I am checking if it is valid or not. Then it send to our Python request. It send and get the data, specific data what the user are requesting. Then all the RAG and FAISS vector data we are saving, all the processing will happen in our Python server. Then it get the data response back. When the data is coming successfully, it will convert in JSON and and send them. Then I have created a, this is coming in JSON. So I am joining the document. I have creating a context in this to use join function. So this contact I have attached to, you can see I have attached in payload. This will be our payload that will interact with our model. So the model will be our model llama 3.2, the role of a system, and the content. And I have given the brief instruction how what the model should do. As you can see, you are an advanced oncology research assistant, AI assistant, specialized provide in the evidence based and up to date insight on oncology. The list goes on, and then you can see in the last I have attached a context. So this context I am getting from the Python server. Then all of this payload will send to the our model. You can see I have for now I have used local. In demonstration part I will use our hosted, like our hosted model on VPS on AWS. I will show you and show you the URL. For now I am using the localhost, and this will send to our model. The method and header will be same as application JSON, and our payload will send to the our model and get the response. When we are getting the response, it send back to our UI. This is, so I am handling the data, like it getting a response. So I am filtering out all the, removing all the typos and different star to make a content a good, to it appealing, visibility is very great to see. So this in our, this all happening in our API in TypeScript project. So the Python will be in this. So I have used Python as a, the main logic are developed in Python, RAG implementation logic. Why I've used Python? When we are dealing with AI and machine learning, the best way to the best way possible to get the job done in Python. Like it is the most efficient way you can use it. The most of the library for AI and machine learning are available, like FAISS, and there many more libraries exist to get the job done. Other than uh, TypeScript and JavaScript, it is a little bit difficult and not efficient way to train model, or like other stuff for training or dealing with AI and machine learning. So I have used AI to deal with RAG implementation, model training, and the main getting embedding and use of Facebook AI similarity search. So let me tell you why I am using Olama for getting embeddings. So it is mainly, the base model is based on Llama 3.0. So we use API slash embedding with Llama to generate high dimensional text embedding, enabling semantic search by capturing meaningful of research paper rather than relying on an exact keyword. These embedding are stored in a FASS and in FASS, FAISS, a fast and scalable vector database, allowing efficient similarity search to retrieve the most relevant oncology research document. So with this embedding, we can interact with our FAISS vector database efficient as possible. So uh, then you are getting a question about what is FAISS, FAISS. So it is a lightweight and open open source vector database. It is created by Facebook. So the FAISS, Facebook AI Similarity Search in is a open source library developed by Meta, Facebook AI Research, for efficient searching of similar vector large dataset. It optimized for high dimensional data and widely used for semantic search, image retrieval, recommendation system in AI powered search engine. Why we use vector database like FAISS? Traditional database such as MySQL, SQL or NoSQL work well with structured data but struggle with a semantic similarity search. Fast FAISS solves this, storing high dimensional vector and enabling fast nearest neighbor search, making it perform for RAG like we have used in our model, Retrieval-Augmented Generation, semantic search and question and answering, large scale AI powered search, image and video similarity matching. How fast work, and you are getting how this work, this library. Fast indexes are searched through large collection of vector embedding like that we are creating with llama, the embeddings, using approximately nearest neighbor ANN search algorithm. It provide indexing, searching and performance. In indexing, storing embedding in an efficient format. In searching, find a vector similar to query vector using distant matrix. Optimized performance uses CPU, GPU. We can, if you don't have dedicated GPU, we can still use this vector database for searches of billions of vectors. The key, let me tell you the key concept in NNS, nearest neighbor search. Instead of computing every stored vector manually, fast FAISS quickly find the most similar ones using the efficient indexing technique. For example, convert oncology research paper into embedding vector representation. Store this vector in FAISS. When a user query, convert their input into vector and search the nearest stored vector. Retrieve and display retrieval research paper. So, uh, these are all the information about FAST, Facebook AI similarity search I have used. Uh, as you can see, I have used Fast API to integrate with. I have, like, the object is created in app, and I have used mainly for storing, like, for research paper. I have created a different collection of documentation document in Mongo, that all the research paper and all the PDF research paper text and all the data stored in that. So it retrieve the information, vector, embed it and store it. I will show you how are going work. So this, like you can see, this is the Mongo client are creating with my URL. It linked with my MongoDB database. My collection name is document DB, and I have used it is uh, it is doing the mapping. So first, when we are it when we start the project, it find the index byte file. I've create this fast index and index.fast. uh, with this function I have created, uh, this dimension it is very specific based on the llama model we are getting. So we have to first test what the dimensionality of that model, then it get the information we have. So this used to get the information and create, write the FASS index. This, so it is very useful to get this FASS index. So this is my main application for to get the retrieval information. To get the embeddings, I have used this function. They are this using first of all it's sending like it using the model URL or model name and the and URL to get from the embeddings. It get embedding from my llama model, and I have created this function to extract from PDF. Like when you are giving, like for example, I have sending in Mongo. I have sending my PDF using Postman API. So when I have sent in this URL, in this URL I have sent my PDF, then it mm, convert text from the PDF, then store on my MongoDB. Yeah, on event, this is the startup when we are start the project. It is very important. Like to upload the abstract, I have also used you can store directly text or document using this function. This function is for upload research papers, and this function to get the embedded requested data using query. When I am using in this, I am using a query like our Python function and query. This get the response from that. So this is all I've created to get the requested result for the user. The whole project I have explained you. I will demonstrate you and show one by how the process are working, how the data are collecting, storing. So in my MongoDB, so what the document I'm storing, you can see the documents in document section. It's loading. So the document, you can see, if I can, like, yeah, so I have stored a text document in that, a long list of document that it can retrieve when I'm using my API to get the information. The research paper are stored in my Mongo, and I have stored multiple, like I have stored 10 of them for testing purposes, and the fast mapping are stored in this. So it is very efficient to get information. It using the mapping that get information. So let me tell you about how I fine-tune my model. So this is all I've stored my data and retrieve my data, and then applying it, getting a relevant data and sending to my backend, and then backend send to my model. When I get response from the model, it again send to my UI that will display on a screen. So let me tell you about how I fine tune my model. So I have used this Unsloth. It is very great to fine tune model for free. I have used this for train my model. So let me tell you about how the process and how the thing I have done. So to fine tune Llama 3.4 oncology specific tasks, Using your dataset, you can utilize Onslaught, a tool designed to optimize and fine-tune process for a large-scale language model. I have created a step-by-step guide. First of all, you can see they have done all the heavy lifting for us. You just have to provide a data set. You just have to provide data set and train your model and run one by one. Prepare your data. Prepare your oncology data set. Data collection. Gather oncology related text data such as research paper, clinical trial, reports, medical record. Data formatting. Structure the data appropriately, ensuring it format suitable for model training. Set up for fine tuning environment. Google Colab. Onslaught provide a beginner friendly Google Colab notebook for facilitate the fine tuning process. Access the notebook, navigate to, like, I have you can search it like llama 3 point onslaught. For llama 3 point to fine tune model, you can search is you can also go to onslaught GitHub repository and select the appropriate notebook for llama 3.2. Upload your data within the collab environment. Upload your data, oncology data, to fine tune llama 3 point with onslaught. Initiate fine tuning. Run the cell in the book to start fine tuning process. Onslaught optimize this process, making it 2x faster and reducing the memory usage by 60% compared to the traditional method. They have mentioned, and you just have to run it, like provide the data, make some changes, and monitor process. The notebook provide real time feedback on training metrics, allowing you to monitor the model performance. Deploy and utilize the fine tuning model. Export the model after fine tuning. Export the model in your preferred format, or upload it promptly like Hugging Face, or like I have did in uh, in my VPS, AWS VPS. So you can do that. So this all the process that it is very easy, and they are done the heavy lifting for us. You can do it by yourself. You can do it for yourself. So this is my AWS. So this is very important to me to showcase you. uh, this is my I have for testing for myself, I have get a free trial EC2. Let me show you the instance that first of all, I have uh, created the created this instance, and I have installed Ubuntu shell in that VPS. uh, it taking no GPU but 8 GB RAM, or 2 CPU core maybe. So let's connect this and show you how. This is my VPS. I'm connecting to my VPS. So as you can see, this is my VPS are connecting. So when I will send a request to my model, it get response from this. And it is available on like publicly. Only therefore only I can access it, but it is not I am done like I am doing not locally, like it sending requests and getting requests not locally. It sent through via our AWS VPS. So I will change this and I will demonstrate how I am integrating with this, like our hosted model. The model is hosted on a VPS server on a different location. It not located in locally. So the all the heavy lifting, performance, GPU usage, anything are happening our VPS. So let me tell you the VPS and AWS. Amazon Web Service. Amazon Web Service is a cloud computing platform. As you can see, it is a cloud computing platform that provide on-demand computing power, storage, database, networking services. It operate pay-as-you-go pricing model, meaning you only have to pay for the resources you use. The key feature of AWS: scalability, global availability, security, managed service, data management, and E2C. Like I have used this virtual machine. Use cases for AWS: hosting web application, running AI ML models like I have did, storing and managing big data, and deploying microservice API. So in hey, so as you can see, I will demonstrate you how our oncology AI research are working, how it getting the information, and how it visually appealing to the user. As you can see, the UI is very appealing to the user. It created very nicely. Given the I have added SVG icon, a good coloring, a good UI. Like, so I have run this project and test myself. As promised, I will show you. uh, I have added my AWS VPS link, so you can see that HTTP ES2, like this is the like public network maybe, and compute one Amazon AWS.com, and this is the port number of our Olama and API chat. So I am interacting with our hosted, like it is my model is hosted on a different server. Now I will integrate it. Like, first of all, I will send hi for test. So as you can see, the background icon has gone, and look at the animation, it giving the typing animation. So I have created like all the when all the processing are complete, it get the response directly. I have created simple UI for this, not like ChatGPT level, but it will be appealing to you, and it will generate the response, and all the process are happening in all background. Like, is first sending, like you can see that like compiling, like compiler happen. This is for yeah, as you can, the post requests are successfully done. 200, my response code is 200. That's mean it send my API successfully to the backend. You can see all the process are happening. Yo, let's see the response are generated. Hello, how I can assist you today? Are you the sorry researcher, medical professional, or student looking for the information on oncology? Do you have a specific question? Like, I can prompt it, tell me about cancer. It will again process the information, use I have implemented a RAG, Retrieval-Augmented Generation, using fast vector database. It like all I have explained you, all the are happening in all the processing are happening. Let me show you again. And the get is 400 for, like, what do you mean by 404? It's like mean not found, the logo PNG is not founding, so it giving me that. So when you are seeing the Python server, how my Python server looking, so I have started, uh, I have get the package unicorn document embedding, like it. huh and as you can see, the embedding also I'm getting from my URL. The post request from the query, post query are 200. Okay, so it's still processing. It gave me some give some time, it generate the data soon. And you can ask any question about it. It can any question, but mainly focus on our oncology research. Like if you are a research scientist or research, you can use this project to get the specific information. It is very the model trained on our oncology research, oncology research paper, and the pipelining are handled using a RAG. Like all the information are based on specific information. It is a very specific on our oncology. So it will take time. All the When all the texts are generated, it will send my answer. I will fast forward this to get you answer soon enough. Still processing. So the process are happening. So you can see it gave me very large response. You can see, and very comprehensive guide. All the data are filtered and give me. So you can see the cancer are the complex multifactorial disease. Like it giving me answer based on my I have sent the document. Like I have uh, like it retrieving the information based on our RAG implementation, based on our topic. Cause of cancer, like cancer is a group of disease character, uncontrolled group. Like it giving me answer that we are provided. I have trained this model and applied RAG implementation on it. You can see the model are working perfectly fine. Everything is working very good. So you can see in my Python backend it sent the request. Like it is working, like the contacts are getting fine. We have it is running fine. It's telling me okay. You can see like I'm not faking it. It is running in real time, and you can, when I host this project, you can use it. It will get take some time to get the answer. uh, because I'm using a free trial, so it running on 8 GB, 8 GB RAM and 2 core CPU. And if we are going enterprise, we can use 16 GB, like we can use 30 GB RAM and 16 core, and also with GPU. Then it will get very fast response, like in within a second, like chat GPT. So like you can see we have completed our course, like our project within 4 days. I have created, like you can see the my front end and back end are in Next.js and Python in in, and my on legitimate logic are based on in Python. Let's get this prompt and we can warp up after that. For embedding, I'm also using my hosted data, my hosted VPS, like my hosted model. I'm using that from this. You can read it in detail. It giving me answer based on the research paper I have provided and trained it. So like it is giving me up to date answer and a very specific, not like in a general. If I have I want to contribute in this project, like he gave me an answer. So you can see it gave me very large response because I have trained the model in very large data set. You can read it if you want in detail. It gave me. So I have created this project within a 4 days, and you can see it is working fine. Thank you so much Lunatech for giving me opportunity to create this such interesting project to help the research scientists, students and doctors. Thank you very much Lunatech. As to warp up things, uh, I will tell you brief summary about our whole projects: Oncology Research RAG, and AI powered Retrieval-Augmented Generation for all oncology research. So, imagine an AI that can instantly retrieve and analyze oncology research paper, providing accurate research back insight. Welcome to Oncology RAG, Research RAG, an advanced AI powered augmented generation system designed to revolutionize how we explore oncology research. So, to project overview, the Oncology Research AI project leverage AI and vector search techniques to provide accurate research backed responses on oncology related query. It combines semantics search and AI generated answer to assist researchers, doctors and students in navigation complex oncology data. How does it works? First, a user submit an oncology related question. The system search to a vector database to find systematically similar research paper. It retrieve relevant document from MongoDB and augment them with AI generated insight. Finally, the Olama OI 3.2, a fine-tuned model on oncology research, generate a precise response. This enhanced research capability by combining retrieval and intelligent response generation, ensuring user get accurate and constructual answer. For to the next slide, tech stack. The core technology behind it: front end built in Next.js, ensuring a seamless UI and API integration. Back end deployed with a like also it is developed on a Next.js with a API, handling API requests, data flow efficiently. Database MongoDB storing oncology research paper, vector search for storing oncology research paper, vector search and optimized similarity search engine that help retrieve relevant paper quickly. Search and API, fast API manage FAISS based vector search and embedding AI model Llama 3.2, which is fine-tuned with oncology research paper to generate high-quality responses. This tech stack ensure The system efficient, scalable, and accurate. This process delivery oncology research insight. For the next project architecture, how it works. A user query. A user submit a research question related on oncology. Document retrieval FAISS. Facebook AI similarity search. Search the vector database for the relevant oncology paper. Data augmentation. Once the retrieve, additional research paper are fetched from MongoDB for context. AI powered responses. Llama 3.2 processes retrieved information and generate insightful knowledge. Final output. The AI send detailed research backed response to the user, helping them with the precise information in seconds. This architecture ensures the user retrieve the most relevant information, research back insight, improving efficiency on oncology research. The workflow. So as I have present this earlier, this is our architecture. How our the whole, like I have get this model represent the in-depth detail how it going to work, like how the data flowing are happening, how the pipeline handling are done, how the integration with Olama, how RAG are applied. In conclusion, the oncology research RAG project showcased the how AI and RAG can revolutionize the way we access and process the medical research. It enables fast and accurate research retrieval. It provides context aware AI generated insight. It bridges the gap between complex research data and user friendly AI component. This innovation has immense potential to assist doctor, researchers, students in finding oncology related insight efficiently. Uh, this is all my project overview. Thank you so much for the Lunatech for giving the opportunity to present myself. Thank you so much.